solve all the previous year JEE Mains questions, all the important questions or the more tough questions that were asked by JEE Mains from this chapter. Now again, as we have been doing this from the previous lectures as well, I wouldn't be giving you any options, so that the toughness of the questions become more and you are able to solve the question by the formula and by the method how they are solved, and not apply any shortcut trick by using options or a hit and trial method. This way it will help you learn the chapter, so that when you are on the spot giving the examination of JEE Mains, it becomes easier for you to give and solve any type of question that has been provided to you. So let's start with the first question. This was asked in JEE Mains 2020, and by the look of this question you can understand that this is from the shortcut table that I had just taught you. The mean and standard deviation of 10 observations are 20 and 2 respectively. Each of these 10 observations is multiplied by p. So you see that the constant term that is getting multiplied to each and every term here is p, and then reduced by q. That means each term is getting reduced by q as well. If the new mean and new standard deviation become half of their original values, then q is equal to. Now this question is simply just a piece of cake if you know the shortcut table that I just taught you. Let's write down whatever information has been provided to us. N is equal to 10 here, since there are 10 observations. Mean we see to be 20 and our standard deviation is 2. And we know our new mean and new standard deviation, which we represent by x bar and sigma bar, these have become half of their original values. This means this has become 10 and this is 1. Now let xi be the data set of which we have taken the observation, and here I belongs from 1 to 10. Now it has been mentioned in the question that each and every element has been multiplied by p first, and then they have been reduced by q. So now what would be our new variance, standard deviation and mean? So let us first look at mean, calculation of mean. So this is the old mean, which is 20. Now for new mean, we can simply use the shortcut trick that we had studied. If there is any constant term multiplied, then our old mean would also get multiplied by that constant, and if any constant is subtracted, our mean would also get subtracted. So simply our mean would also be this. That means p x bar minus q, which is our x bar dash, this is equal to 10. So we've got one equation. Here we know the value of x bar, which is 20, so we can replace that later while we are solving the equation. Now let's do for sigma, which is our standard deviation. I hope you all remember that if we are calculating new standard deviation and if any term gets multiplied, then we know the standard deviation would change with mod p. I'm sorry, this will not be x, this will become sigma. And if any term is added or subtracted, it has no effect on either of variance or standard deviation. So similarly, there wouldn't be any weird difference here. So, and this value is equal to 1, as it was mentioned in the question that the values have become half. Now upon solving these two equations that we've got, which is p 20 minus q is equals to 10, and this one where we know the value of old sigma to be 2, so 2 mod p is equals to 1, mod p is equal to 1 by 2. So p can be either plus minus 1 by 2 if we remove mod. Now let's put the equation of p to be plus 1 by 2 in the first case and p equals to minus 1 by 2 in the second case. Or wait, in the question it was given that p is non-zero and q is also non-zero. So we need to remember this information while solving. So p is half, so this would become 10 minus q, which is equal to 10. 10 and 10 would get cancelled and q would turn out to be 0. Wait, this is completely opposite to what was given in the question. The question had mentioned that q is equal to not equal to 0. That means we cannot take this value of q to be our answer, so this gets rejected. That means we have to solve q for p is equal to minus half. This would become minus 10 minus q is equals to 10, and q would equal to minus 20. That means our value of p is minus half and our value of q is minus 20. This is how we get the answer. And what was asked in the question, then q is equal to, so we had to find out the value of q only, and that was minus 20. So this is how we get the answer. So one major thing that you learned from this question was always try to read the question in a complete manner, because no information provided in the question is going to go vague without any use. So for example, here p is not equal to 0, q is not equal to 0. At the first glance you think that this is just a waste of information that has been provided to you. However, while solving you came to this conclusion that q can also be 0 if p is equal to plus half, and p can take up two values which is plus half as well. So you have to reject that value and take up the other value of p. So that is how you calculate questions values when there are two or more answers possible. Now we'll move on to the next question. If 5 observations are 2, 4, 10, 12, 14, then the absolute difference of the remaining 2 observations is. So I hope you can see that the question has mentioned you that there are 7 observations. However, it has only provided you with 5 of them. That means 2 are missing. That means in this question you have to assume those 2 observations, let's say to be x and y, and then try to solve the equation for mean, because mean has been provided, and solve the equation for variance as it has also been provided. So you would have 2 equations, 2 variables, plain simple, without any logic, just formula based questions. So let's try to solve it. So x bar is given to us, which is 8, and sigma square is given to us to be 16, and we know n is equal to 7. So the observations given to us are 2, 4, 10, 12, 14. Let us assume that the other 2 observations are x and y. Sorry, not x plus y. This is going to be x and y. So now let's calculate mean as per these observations. So we would get mean. Mean is what? Sum of all the observations upon number of all the observations. And this is ungrouped data, so it becomes more easier for us. 2 plus 4 plus 10 plus 12 plus 14 plus x plus y divided by 7, and mean is 8, so we'll cross multiply this, we would get 56, and this would be equal to 2 plus 4 plus 10 plus 12 plus 14. So this would give us 42 plus x plus y. So from here we get the value of x plus y to be 14. So we've got one equation through which we can solve our question. Now let's look at for the other equation. Sigma square is given to us, which is 16, and we know the formula of variance is summation x I minus x bar whole square upon n. So now if I were to break up, if you remember, we had studied the formula of alternate formula for standard deviation, which was summation xi square upon n minus summation xi by n whole square. So this basically makes up the mean, summation xi by n. We can use this formula to calculate the variance as well, since this is the standard deviation, and we know that standard deviation is the root of variance. So we just need to remove the root from this equation and we would get our variance. So in simple language, this formula can be written as sigma xi square by n. Sorry, this would be minus x bar whole square. So this would become our variance. Now let's put on the values that have been given to us in the question. 2 square, this would become 4 plus 16 plus 100 plus 144 plus 14 twos are, we would get 196, and plus x square plus y square whole divided by 7 and minus x bar square. So we know the mean here is 8, so 8 square would become 64 and this would be equal to 16. Now let's try to simplify this equation a bit more so that we can find out the second equation. Let's take 64 to the other side and let's sum all these numbers together. So we would get x square plus y square plus 460 upon 7 minus 64. This would be equal to 16. Now upon equating further, we would get x square plus y square to be 100. So we've got our second equation as well. And what was asked to us in the question, we had to find out the difference of the two observations. That means we need to find x minus y is equals to question mark. So this is what exactly we need to find out. So we know our first equation is x plus y and that is equal to 14. So let us just take the value of x to be 14 minus y and substitute it in this equation. So we would get 14 square, which is 196, plus y square minus 28y plus y square is equals to 100. And upon equating further, we would get y square minus 14y plus 48 and this would be equal to 0. I hope you are understanding. I'm just writing down the direct way how you can get this equation. Now let's try to solve this question. Now you can solve it either through factorization method or using the solution of quadratic equation. However, by the look at it, you can make that out that y minus 6 and y minus 8, these two would be the factors of this quadratic equation. That means we've got the value of y to be either 6 or y is equal to 8. That means we need to find out the absolute differences for both these things. Now if let's say y is equal to 6. Now let's say y is equal to 6, first condition. So x would become 8 and let's say y is equal to 8, then x would become 6. So in both the cases, if we find out the absolute difference, let's say x minus y, absolute difference is basically x minus y mod. So this would become 2 and here also x minus y mod would become 2, and that is exactly what was asked to us in the question. We needed to find out the absolute difference, so our answer is 2. Now this was a fairly lengthy question, I would say, according to JEE Mains, because the concepts that were used were very easy. However, the calculations required in this question was very lengthy, so this would have taken a little time. However, only patience would have helped you achieve this question correctly. Let's look at the other one. Let xi, and this question was again asked in 2020 in another shift, 1 less than equal to I less than equal to 10 be 10 observations of a random variable x. So here in this entire question, you can make this out that the random variable x has been assigned as xi minus p. If you see, there are two equations given to you, xi minus p summation gives you 3 and summation of xi minus p whole square gives you 9. So you have to use these two equations to find out the standard deviation. And I hope you know the formula for standard deviation, which is root under sigma xi square by n minus xi by n whole square, sigma xi. This can be written as mean, of course, mean square. And here if you look at the equations properly, you see xi minus p, that means here the xi term has been provided to you, and xi minus p whole square, that means this term has also been provided to you. Now you can simply replace xi square to xi minus p whole square, because I had taught you in that shortcut table trick where you had learned that whenever any constant k is added or subtracted to all the values of the dataset, the variance or standard deviation does not change, it remains the same. So this would create no effect on the standard deviation. So we can simply write down the formula of standard deviation to be root under summation xi minus p whole square upon n minus summation xi minus p upon n whole square. Now I hope you've gotten the gist of the formula used in this question. Now the question has become very easy for you to solve. You just need to substitute the values. Summation xi minus p whole square is 9 and the number of observations given to us is 10 minus xi minus p, again this becomes 3 by 10, and squaring this we would get 9 by 100. So from here we would get the value to be 81 by 100 root under. This would be equal to plus minus 9 by 10. Now of course, since this was a numerical based question and it has been mentioned here that 0 is not equal to p belongs to r, this means negative answer cannot be considered here. You have to reject that. So our answer to this question would become plus 9 by 10. A very easy question, very easy question. Only thing was you had to remember the concept that whenever a constant is added or subtracted to all the terms of a data set, the standard deviation and variance remains constant. They do not change. If you were able to find out that, then the question is very easy. Just you needed to substitute the values into the formula. Now let's look at another question. This was a good question that was asked in JEE Mains 2017. The sum of 100 observations and the sum of their squares are 400 and 2475 respectively. Later on, 3 observations were found to be incorrect if the incorrect observations are omitted. Now omitted here, I hope you all understand, this means removed. Then the variance of the remaining observations is. So basically the observations that we had was somewhat like this, and somewhere in between we had 3, 4 and 5 as well, and this continued up till x100. Now in the new data set we have been told that we have only 97 terms up till x100. However, 3, 4, 5 have been removed. So here we had 100 terms. Now we would have just 97 terms. So our new n would become 97. You needed to keep this in mind while solving questions. Now it has been given that the sum of all these observations, that means summation xi I is equal to 1 to 100 was equal to 400. So on simplifying this so that we can remove 3, 4 and 5, we can write this as summation xi I is equal to 1 to 100 minus 3 minus 4 minus 5. This would give us 388. Now this is based on 97 terms. Here I does not go up till 100, it goes up till 97. You needed to remember this thing. And the squares is 2475. That means summation xi is equal to 1 to 100 square. This is given to us to be 2475. And now if we remove these 3 observations from the squares, then we would get I is equal to 1 to 97. Let us assume that those 3 numbers 3, 4 and 5 are the last observations. So we would get xi square minus 9 minus 16 minus 25. This would give us 2475. So from here summation xi square I is equal to 1 to 97. This would be equal to, we have to add all these values into this. We would sum all these values to sum all these 3 values and then subtract from this one. So we would get 2425. Now what was asked to us in the question? We have to find out the variance of the remaining observations. Now it becomes fairly easy. Now that we've found out the new square, new data set squares summation and the new data sets sum. So we know the formula for variance is equal to summation xi square upon n minus x bar whole square. So we can write this down as 2425 by 97 minus, and x bar can be written as summation this, which the new one is 388 upon 97 whole square, and from here we would get this would cancel this by 25 and this would cancel this by 4. So we would get 25 minus 4 square would become 16 and 9. This would be our answer. Again, another easy question. There wasn't much brains that you had to use or any concepts that you had to use. Only the thing was you had to understand the formula and how they are used in variance and other things. Now let's look at another question. So now this question, which was asked in JEE Mains 2023, not very later. Let sets A and B have 5 elements each. Let the mean of the elements in set A and B be 5 and 8 respectively, and the variance of the elements in set A and B be 12 and 20 respectively. A new set C of 10 elements is formed by subtracting 3 from each element of A and adding 2 to each element of B. So we've collaborated both these sets, which have five elements, to make it to a one single set, which makes it of 10 elements. Then the sum of mean and variance of the element C is. Again, easy question. Just the thing is you have to do long and lengthy calculations in this question as well. So here set A has been given. Let's say they are x1, x2, x3, x4 and x5, and we know the mean of these elements are 5, and there is set B given to you. Let's say this is y1, y2, y3, y4 and y5, and y bar has been provided to you to be 8. The variance has also been provided, sigma square, which is equal to 12, and sigma square is equal to 20. Now a new set C has been formed. So set C, it has been formed by subtracting 3 from each element of A and adding 2 to each element of B. That means this set would become x1 minus 3, comma x2 minus 3, comma x3 minus 3, comma x4 minus 4, comma not 4, this would also be 3, x5 minus 3, and adding 2 to each element of A. So this would become y1 plus 2 plus 2, y2 plus 2, y3 plus 2, y4 plus 2 and y5 plus 2. So we've got 10 elements here, and now we have to find out, let's say the mean is represented by C bar. We have to find out this, and we have to find out the variance, sigma dash square. So let us first try to find out the mean, because it is going to be very easy for us since we know the properties that were used in finding mean, and we also know how to find out weighted mean. So again, the shortcut trick that I had taught you, you have to use that here. So C bar, can we write it down as weighted x bar plus weighted y bar. So if I was to find out the new x bar first, let us find out new x bar first, which will become 5 minus 3, since all the terms have been subtracted by 3, and we remember if all the terms of a set are added or subtracted by a constant term k, then the mean would also be added or subtracted by that constant term k. So we subtract 3 here and we would get 2. Similarly for y bar, we would get it to be 10. And since we know that we have 2 means here and we know the number of elements in both sets, which is 5, so we can find out the weighted or the combined mean here. Since we need to find out the combined mean, we remember the formula to be n1 x1 bar plus n2 x2 bar upon n1 plus n2. So by this we can find out 5 into 2 plus 5 into 10 upon n1 plus n2. This would become 10, and this would ultimately come out to be 6. So we've got the value of C bar to be 6. Now let's try to find out the variance. Now for variance also you can use the same combined mean formula. However, that would become a much difficult and much lengthier version for you. So let's try to find out in some different way. So for C, sigma C square, we can write this down as summation xi minus 3 whole square, since this is the first set, plus summation yi plus 2 whole square, this entire thing divided by n minus mu, or let's represent this by c. Isn't this the formula for sigma square, where we sum the squares of all the points on the data set divided by the number of points in those data set minus the mean whole squared? So that is exactly what we are doing here. So this, now this thing can be written as sigma xi minus 3 whole square upon n plus sigma yi plus 2 whole square upon n minus c bar whole square, and we know the value of c bar, which we had just calculated to be 6. Now this entire thing, since there are 10 observations now, this can be written as 5 into 12 by 10. I hope you are understanding how we are getting 5 into 12. This initial standard deviation was 12, and we know xi minus 3 whole square would be 12 into the number of elements. So we are basically trying to take out the weighted mean for just the first part of the variance and not the second part. So similarly for this one, we would get it to be 5 into 10 upon 10 minus c bar, which is, let's write it down, the value 6 whole square. So from here we would get 6 plus 5 minus 36, which would turn out to be 25, minus 25. Now I hope you understand that minus 25 cannot be the answer. Variance cannot be equal to a negative number. That means the answer that we've calculated, this is incorrect. So we have to try to find out this through some other method. So let's see how we can do that. We know sigma 1, let's say this is sigma 1 square is equal to 12, and sigma 2 square is equal to 20. Oh, I'm sorry, I had made a calculation mistake here. It wouldn't be 10, it would be 20. So from here we would get this to be 10, and from here we can get this to be 20. Again, the same thing, since the value is coming out to be negative, we need to find it out using some other formula. This is 20, I'm sorry for that. Now I hope you remember we had also studied a formula for combined standard deviation. So same formula can be applied for combined variance as well. Only the thing is we need to remove the square root which was applied there. So for combined variance, the formula would become n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 upon n1 plus n2 x1 bar minus x2 bar whole square divided by n1 plus n2. If you do not remember, I'll show you what the formula was and where we studied it. Here, if you remember, we had studied this sigma combined formula, n1 sigma 1 square plus n2 sigma 2 square, n1 n2 upon n1 plus n2, x1 bar plus minus x2 bar whole squared upon n1 plus n2. So this was standard deviation. For variance, we just need to remove the square root. and we would get the combined variance. So now here you can put down all the values that we've gotten. 5 into 12 plus 5 into 20 plus n1 into n2, 25 by 10 into x1 bar, the new mean was 2, and y bar is 10. So we've gotten this to be 2 and 10. So 2 minus 10 whole square divided by n1 plus n2, which makes it 10. So from here we can solve this equation. This would become 64 square. This can become 5 5s are 25, 5 2s are, and this would cancel this 32 times, and from there we can get our answer to be 32 at the end. So therefore, what was asked to us in the question? The sum of mean and variance of elements of C. That means we had to find out plus sigma C square, 32 plus 6, and this would give us 38. And we've got the answer. Again, a lengthy question. It did not have much concepts to use here. Only thing is, if you had remembered the formula for combined variance and remembered this concept that variance can never be negative, thus you would have solved this question. So now let's look at another question. What has been provided to us in this question? Let the mean and variance of 12 observations be 9 by 2 and 4. Later on, it was observed that 2 observations were considered as 9 and 10 instead of 7 and 14, respectively. If the correct variance is m by n, where m and n are co-prime, then m plus n is equal to. Again, similar question as to previous one. So there were 12 observations, out of which 2 were incorrect. Now, instead of removing those 2 observations, we have to take the correct value of those 2 observations, which is 7 and 14. So let us first look at how we can do this. So let's say there are 12 observations. Let us consider 7 and 14 to be the last observations. So instead of considering this, the mean and variance were calculated by considering 9 and 10 as the last observation. So let us find out what is the mean through this. X bar is equal to 9 by 2. So what would be the X bar for this data set now? So from here we can see that this is summation xi from 1 to, from 1, I is equal to from 1 to 10, summation xi plus 7 plus 14. Or instead we can write this down as summation I is equals to 1 to 12 plus 7 plus 14, and then we subtract 9 as 10 as well. So we would get the same answer. So from here now we can find out that what is the value of summation xi. That can be calculated from this equation here, and we can do the rest of the calculation mathematically. So here summation xi is equal to from 1 to summation I is equal to 1 to 12 xi upon n is equal to 9 by 2, and n is 12, so 2 would cancel this by 6 times. So summation xi from 1 to 12 can be written down as 6 9s are 54. So here we can replace this value 54, and this would become plus 21 minus 19 upon 12. So the new mean that we get here is 54 plus 21 would give us 75, and 75 minus 19 would give us 56 by 12. And we can further simplify this. 4 3s are 12, 4 1 14s are. So 14 by 3s are new mean now. New mean. Now let's take a look at the variance calculation from here. So in the variance, initially summation xi I is equals to 1 to 12 whole square upon n minus x bar whole square was equal to 4. And now for the new observations, we can say that xi square, I is equals to 1 to 12. We can add 49, and what was the other term? It was 14, so plus 196. And we can subtract these two terms, 9 and 10, so this would make it minus 100. Since we are subtracting and adding the squares of numbers, so that is why I have directly written it. This would be by 12 minus, what is the new mean that we've gotten? 14 by 3, and this would become 14 by 3 whole square. This would be our new variance. So from this equation, let us first try to find out what would be the value of xi summation whole square. So here in this equation, the value of x bar that you have to take up is 9 by 2, because this is the old equation which did not have the correction happened. This was calculated using the terms 9 and 10 only. So from here you would get xi square by 12 minus, here we have 9 by 2, so it would become 81 by 4 is equals to 4. Let us take the LCM. 12 summation xi square minus 4 3s, so this will become 243 is equals to 4. So summation xi square would be equal to 48 plus 243, and this would become 291. So now we can replace this value here in this equation and get the value of our new variance. So let us do that. 291 plus, this would become 5, 1 carry over, 24, 245 minus 181 upon 12 minus 196 by 9. Furthermore, we can write this down as, let's take the LCM. So the LCM of 12 and 9 would become 36, which would be, so let's first calculate this. 291 plus 245, this would give us 536, and then subtracting 181 from here, you would get 5, 4, 5, 3, 355. So since 12 3s are 36, so we would have to multiply 3 as well to this equation, to this number. We would get 5 3s are 15, 3 5s are 15 plus 1 16, 10. So we would get 1065 minus 9 4s are 36, so 196 into 4 is what we have to do. 6 4s are 24, 9 4s are 36 plus 2 would give us 38, and 784. And upon solving this, we would get 1, and 78 minus 106 would give us 28. So this was our answer. Now we can try to simplify this more as well. 3 does it 12 times, 3 9s are 27, 3 7s are, so our answer would become 97 by 12. What was asked to us in the question? The question was asked was if the correct variance is m by n, where m and n are co-prime. So we can see that 97 and 12, both these are co-prime numbers. That means these two numbers, the common factor between these two numbers is just 1. So that means m and n are co-prime and m plus n is equal to. So we had to find out 97 plus 12, and this would give us 109 to be our answer. This is our answer. Again, a very simple question. The only thing required in this question was patience. You had to solve it till the end. There were a lot of big calculations, time-taking calculations in this question, but again, an easy question. So that was all for this chapter, mathematical statistics. As I mentioned at the start of this chapter, a very easy chapter, although a very important chapter, because in each and every JEE Mains paper you will see that there has been one question asked directly based on the formulas of this chapter. So definitely a chapter if nobody should miss and practice thoroughly. Thank you.